What if the greatest scientific fact you've ever been taught wasn't a fact at all? What if the Earth isn't flying around the Sun at 66,000 miles per hour or spinning on its axis at 1,000 miles per hour, but is actually completely still? We continue to explore one of the most controversial, mind-bending possibilities in all of science. The idea that the Earth is fixed, unmoving at the centre, and everything in the universe revolves around it. And this isn't some fringe view. Some of the most brilliant physicists in history, from Einstein to Newton to Mach, have admitted that it may be possible. Not only possible, but scientifically valid. In the previous episode, we showed that bare observations don't disprove the geocentric model, which today is the Neo-Tychonian system, named after brilliant 16th century astronomer Tycho Brahe. But how do we explain the observed forces we see, such as Coriolis? Don't these completely disprove a stationary Earth? As we'll see, not only observations, but also forces are explained more than adequately in a geocentric system. Steven Weinberg, Nobel Prize-winning physicist, in his book To Explain the World, writes, "If we were to adopt a frame of reference like Tycho's, in which the Earth is at rest, then the distant galaxies would seem to be executing circular turns once a year, and in general relativity, this enormous motion would create forces akin to gravitation, which would act on the Sun and planets and give them the motions of the Tychonic theory." Newton seems to have had a hint of this. In an unpublished Proposition 43 that didn't make it into the Principia, Newton acknowledges that Tycho's theory could be true if some other force besides ordinary gravitation acted on the Sun and planets. So even Newton, the father of modern mechanics, left room for a geocentric model, provided the right forces were involved. The Foucault pendulum is often cited as definitive proof of Earth's rotation, with its slow, steady precession seemingly confirming that the ground beneath us is spinning. But what if that motion isn't caused by the Earth rotating beneath the pendulum, but rather by the stars and cosmos rotating around a fixed Earth? According to Mach's principle, the inertia we observe, including the Coriolis and centrifugal forces that affect a Foucault pendulum, arise not from motion in empty space, but from the gravitational influence of all the mass in the universe. Albert Einstein himself affirmed this in a 1913 letter to Ernst Mach, writing, "Your happy investigations on the foundations of mechanics, Planck's unjustified criticism notwithstanding, will receive brilliant confirmation. For it necessarily turns out that inertia originates in a kind of interaction between bodies, quite in the sense of your considerations on Newton's pail experiment. The first consequence is on page 6 of my paper. The following additional points emerge. 1. If one accelerates a heavy shell of matter, S, then a mass enclosed by that shell experience an accelerative force. 2. If one rotates the shell relative to the fixed stars about an axis going through its centre, a Coriolis force arises in the interior of the shell. That is, the plane of a Foucault pendulum is dragged around. In other words, the pendulum's motion can be fully accounted for in a geocentric system. If the rotating shell of the stars induces inertial effects within, what appears to prove Earth's rotation might just as well prove the rotation of the heavens around a stationary Earth. This is the scientifically recognized principle of covariance in action. It's also been known as the general principle of relativity. The main physical agent responsible for the pendulum phenomenon is the non-inertial Coriolis force in the heliocentric model. In the geocentric system, however, we simply take this Coriolis force as a real inertial effect. The next year, in 1914, Einstein wrote the following: "We need not necessarily trace the existence of these centrifugal forces back to an absolute movement of K, the Earth. We can instead just as well trace them back to the rotational movement of the distant ponderable masses, the stars, in relation to K, whereby we treat K as at rest." This quite substantiates the view that we may regard the rotating system K as at rest and the centrifugal field as a gravitational field. In other words, relativity doesn't rule out a fixed Earth, it legitimizes it. The rotation of the stars around the Earth can create forces indistinguishable from those that would be caused by Earth's own rotation. Let's take the bulge of the Earth as another example. Popular science attributes the bulge to the revolution of Earth around its own axis, but we can just as easily attribute this phenomenon to the force exerted by the distant stars revolving around the fixed Earth. Famous English astronomer, physicist and mathematician Arthur Eddington noted, "The bulge of the Earth's equator may be attributed indifferently to the Earth's rotation or to the outward pull of the centrifugal force introduced when the Earth is regarded as non-rotating." Ernst Mach himself said, "If the Earth is affected with an absolute rotation about its axis, centrifugal forces are set up in the Earth. It assumes an oblate form. The acceleration of gravity is diminished at the equator. The plane of the Foucault's pendulum rotates, and so on." In Newton's view, all these phenomena disappear if the Earth is at rest and the other heavenly bodies are affected with absolute motion round it, such that the same relative rotation is produced. But if we take our stand on the basis of facts, we shall find we have knowledge only of relative spaces and motions. Relatively, not considering the unknown and neglected medium of space, the motions of the universe are the same whether we adopt the Ptolemaic or the Copernican mode of view. Other modern scientists agree. André Assis, Brazilian professor of physics at the University of Campinas in Brazil, said this: "We will see that utilizing a Weber's law for gravitation, it is possible to show that when the heaven of stars, or the set of galaxies, rotate together around a test body, centrifugal forces of gravitational origin act on this body. These forces act on the portions of the body which are not along the axis of rotation. These forces press these portions away from the axis of rotation. Therefore, these portions tend to move away from the axis of rotation of the stars and galaxies around the test body." He goes on to explain how this works. "We have seen Leibniz and Mach emphasize that the Ptolemaic geocentric system and the Copernican heliocentric system are equally valid and correct. The Copernican worldview, which is usually seen as being proved to be true by Galileo and Newton, the gravitational attraction between the Sun and the planets, the Earth and other planets, do not fall into the Sun because they have an acceleration relative to the fixed stars. The distant matter in the universe exerts a force on accelerated planets, keeping them in their annual orbits. In the Ptolemaic system, the Earth is considered to be at rest and without rotation in the centre of the universe, while the Sun, other planets and fixed stars rotate around the Earth. In relational mechanics, this rotation of distant matter yields the force. Now, the gravitational attraction of the Sun is balanced by a real gravitational centrifugal force due to the annual rotation of distant masses around the Earth, with a component having a period of 1 year. In this way, the Earth can remain at rest and at an essentially constant distance from the Sun. The diurnal rotation of distant masses around the Earth with a period of 1 day yields a real gravitational centrifugal force flattening the Earth at the poles. Foucault's pendulum is explained by a real Coriolis force acting on moving masses over the Earth's surface. The effect of this force will be to keep the plane of oscillation of the pendulum rotating together with the fixed stars. Assis then goes on to explain the principle of covariance or equivalence. Again, it's important to note that the term Ptolemaic simply means Earth-centered. The writer is using the Neo-Tychonic model specifically, as this is the only model that explains all observations. We have found a complete equivalence between Ptolemaic and Copernican world systems. It is then equally valid to say that the Earth is spinning once a day relative to the stationary set of distant galaxies, or that the Earth is at rest while the set of distant galaxies is rotating once a day as a whole relative to the Earth. Both worldviews are now equivalent, not only kinematically or visually, but also dynamically, yielding the same flattening of the Earth at the poles, the same precession of the plane of oscillation of Foucault's pendulum relative to the ground, etc. We have deduced the fact that all inertial forces of Newtonian mechanics, like the centrifugal or Coriolis forces, are real forces acting on the test body and being exerted by the set of galaxies. These forces have a gravitational origin and appear when there is a relative rotation between the test body and the set of galaxies. This property explained the flattening of the Earth as being due to the relative rotation between the Earth and the set of galaxies. This property also justifies the fact that the plane of oscillation of Foucault's pendulum at the north or south poles remains at rest relative to the set of galaxies, while the Earth is spinning relative to the galaxies. In the terrestrial frame of reference, on the other hand, the Coriolis's force exerted gravitationally by the set of galaxies and acting on the mass connected to the pendulum rotates the plane of oscillation of the pendulum relative to the ground. This Coriolis force causes a precession in the plane of oscillation of the pendulum, making it rotate together with the set of galaxies around the north-south axis of the Earth. Similarly, Galina Granek from the Department of Philosophy in Haifa University, Israel, wrote the following. According to Einstein, the argument over whether the Earth turns around or the heavens revolve around it is seen to be no more than an argument over the choice of reference frames. There is no frame of reference from which an observer would not see the effects of the flattening of the poles. Thus, in frame number 1, the Earth turns around while the sky is at rest. The centrifugal force is a consequence of the Earth's motion, uniform acceleration, relative to the heavens. This causes the flattening. In the latter frame, number 2, the sky rotates and the Earth stands still. The centrifugal force should be understood as being an effect of the rotating heavens, which is generating a gravitational field that causes the flattening of the poles. The two explanations are equivalent, as there is equivalence between inertial and gravitational mass. The idea that massive objects determine motion and forces aligns with what became known as Mach's principle. And Ernst Mach himself said plainly, all masses, all motion, indeed all forces are relative. There is no way to discern relative from absolute motion when we encounter them. Whenever modern writers infer an imaginary distinction between relative and absolute motion from a Newtonian framework, they do not stop to think that the Ptolemaic and Copernican are both equally true. From a purely observational standpoint, Mach admits there's no empirical difference between a heliocentric and a geocentric model. Julian Barber, historian of science, notes that even Kepler, famous for the elliptical orbits of planets, was driven by something strikingly Machian in his outlook. Kepler's standpoint is particularly interesting since he was deeply impressed by Tycho Brahe's demolition of the crystal spheres. Kepler posed the problem of astronomy in the famous words, "From henceforth the planets follow their paths through the ether like the birds in the air. We must therefore philosophize about these things differently. The planets could not possibly follow such precise orbits by a mere inspection of empty space. They must be both guided and driven in their motion by the real masses in the universe, namely the Sun and the sphere of the fixed stars." Even today's physics still reflects this. Luka Popov, physicist at the University of Zagreb, writes this: "Using Mach's principle, we will show that the observed diurnal and annual motion of the Earth can just as well be accounted as the diurnal rotation and annual revolution of the universe around the fixed and centered Earth. This can be performed by postulating the existence of vector and scalar potentials caused by the simultaneous motion of the masses in the universe, including the distant stars. Popov mathematically models a Tychonic universe using Einstein's own framework, and he's not alone. Fred Hoyle, famous astrophysicist, wrote in Nicholas Copernicus an essay on his life and work. We might hope, therefore, that the Einstein theory would throw more light on the matter, but instead of adding further support to the heliocentric picture, the Einstein theory goes in the opposite direction, giving increased respectability to the geocentric picture. And in his book Frontiers of Astronomy, Hoyle stated, "There is no such thing as absolute spin. The Earth is not spinning to those of us who live on its surface, and our point of view is as good as anyone else's, but no better." From this modern relativistic view, Earth-centered or Sun-centered, it makes no difference. The illusion of simplicity in Copernican theory has also been debunked. Philosopher of science Imre Lakatos wrote, "The superior simplicity of the Copernican theory was just as much of a myth as its superior accuracy. The myth of superior simplicity was dispelled by the careful and professional work of modern historians. I think it is fair to say that the simplicity balance between Ptolemy's and Copernicus's system is roughly even." Even Hans Reichenbach, a proponent of Einstein, admitted this. From the modern standpoint, practically identical results could be obtained by means of a somewhat revised Ptolemaic system. It makes no sense, accordingly, to speak of a difference in truth between Copernicus and Ptolemy. Both conceptions are equally permissible descriptions. And astronomer J.L.E. Dreyer put it even more plainly. The Earth-centered system is in reality absolutely identical with the system of Copernicus, and all computation of the places of the planets are the same for the two systems. If both systems produce identical predictions, then what's the difference? Martin Gardner, in The Relativity Explosion, spelled it out with characteristic wit. One could just as legitimately assume the Earth to be fixed and the entire universe to be moving. The equations are the same. Do the heavens revolve, or does the Earth rotate? The question is meaningless. A waitress may just as sensibly ask a customer if he wanted ice cream on top of his pie, or the pie placed under his ice cream. Similarly, Einstein said, "The struggle so violent in the early days of science between the views of Ptolemy and Copernicus would then be quite meaningless. Either coordinate system could be used with equal justification. The two sentences, 'the sun is at rest and the earth moves,' or 'the sun moves and the earth is at rest,' would simply mean two different conventions concerning two different coordinate systems." Max Born said in his famous book Einstein's Theory of Relativity, "Thus we may return to Ptolemy's point of view of a motionless Earth. One has to show that the transformed metric can be regarded as produced according to Einstein's field equations by distant rotating masses. This has been done by Turing. He calculated a field due to a rotating, hollow, thick-walled sphere and proved that inside the cavity it behaved as though there were centrifugal and other inertial forces usually attributed to absolute space. Thus, from Einstein's point of view, Ptolemy and Copernicus are equally right. Austrian theoretical physicist and Professor Hans Turing said, "Let K, the universe, be a Galilean-Newtonian coordinate system, a system of 3 dimensions extending to the edge of the universe, and let K', the Earth, be a coordinate system rotating uniformly relative to K, the universe. Then centrifugal forces would be in effect for masses at rest in the K' coordinate system, the Earth, while no such forces would be present for objects at rest in K, the universe." Already Newton viewed this as proof that the rotation of the Earth had to be considered as absolute, and that the Earth could not then be treated as the resting frame of K, the universe. Yet, as Ernst Mach has shown, this argument is not sound. One need not view the existence of such centrifugal forces as originating from the motion of the Earth. One could just as well account for them as resulting from the average rotational effect of distant detectable masses as evidenced in the vicinity of the Earth, whereby the Earth is treated as being at rest. If Newtonian mechanics disallow such a view, then this could very well be the foundation for the defects of that theory. If this all doesn't make your head spin, nothing will. So where does it leave us? We've seen that from Newton to Einstein, from Mach to Hoyle, some of the greatest minds in science have all agreed on one thing. Geocentrism is not only viable, it's physically indistinguishable from heliocentrism when approached from a relativistic standpoint. The choice of reference frame is arbitrary, philosophical, even theological. Henri Poincaré, the French mathematician and physicist, took things one step further. He said, "There is no way of settling the question. No experiment can disprove the principle that there is no absolute space." In the famous case between the Inquisition and Galileo, Galileo should be all wrong. But there's another layer to this story that was playing out over 100 years ago. Beginning in the late 19th century, scientists began performing experiments, real physical experiments, to determine whether the Earth was moving through space. And the shocking outcome, the results went completely against their expectations. No motion of the Earth was detected at all. Was Poincaré wrong when he said no physical experiment could prove an absolute rest frame? In our next episode, we'll take a hard look at those experiments, Michelson-Morley, the Sagnac effect, and more. And we'll ask the question, did 20th century physics rewrite the very rules of reality and totally defy common sense just to keep the Earth moving?